Okay guys, Timmy coming at you today. So today what I'm going to try and do for you is I am going to try to explain to you congestive heart failure, and specifically the dilated form of congestive heart failure, where the left ventricle kind of gets stretched out. Let me get my ink. Remember that the amount of blood that's pumped by the right side of the heart is determined by the amount of venous blood that's returned to it. That's called preload. We also learned that both the right and left side of the heart pump exactly the same amount of blood. So if the amount of blood pumped by the right heart is determined by the amount of venous blood that's returned to it, then when the right heart sends that deoxygenated blood to get oxygen and remove carbon dioxide, all of that blood from the lungs will return to the left side through the pulmonary veins into the left atria. Right? Right. Now, in a normal heart, the myocardium is made up of those two contractile proteins called actin and myosin. So let me show you kind of a really crummy drawing that I made. So let's look at this. Now, in a normal heart, when a person is at rest, the actin and myosin are lined up like this. So you have, let's review this, you have that thick myosin filament protein, and hanging off of it are these little myosin heads. Then you have the actin molecule, and the myosin heads have to connect to the actin molecule. And how many of these myosin heads connect to the actin molecule determines how hard that heart muscle is going to contract. Now, when you're sitting on your fatty acid doing nothing, your heart doesn't have to contract that hard because you're not sending a lot of blood to it and you're not metabolically active. So in a resting normal heart, the actin and myosin are lined up kind of like this. So you have actin here and myosin here, and the only place that they overlap is in this area right here. So that's going to determine how hard that heart muscle contracts. So in this case, you can only make two connections between actin and myosin. So the force of contraction of that left ventricle is it's not going to be that strong. But again, this is a normal heart, right? So let's say, for example, that you get up and you run to pick up your textbook. Thank you. And you begin to read it. Or maybe we should make a scenario that would actually happen. But again, I digress. But watch. So, watch. And the right heart and the left heart work the same way. So if you were to add more venous blood back to the heart because you got up and you started moving, and you know there's no pressure in the venous system, by contracting more muscle, you're going to increase venous return to the right side of the heart. So if there's more blood in the right side of the heart, what's going to happen to the right side of the heart? The right side of the heart is going to contract. And it's going to contract harder because the heart muscle itself is going to stretch. So if you send more blood back to the heart, the right heart in this case, it's going to stretch the heart muscle fibers, and it's going to line up the actin and myosin better. So you're going to stretch the actin and myosin in a way that allows them to line up better. And if they line up better, you can make more connections between actin and myosin. And if you stretch that heart and line up those actin and myosin better, right, that's a good thing. You're going to make more connections between the actin and myosin, and that's going to cause the force of contraction of those ventricles to increase. And when you increase the force of contraction, the ventricles are going to eject more blood, so the stroke volume is going to go up. And the pressure with which that blood is ejected is going to go up. So your systolic blood pressure is going to go up. And remember that anytime you increase venous return of blood back to the right heart, what are you going to do to it? You're going to stretch it. That's going to line up the actin and myosin better. Therefore, the amount of blood that's ejected with each beat, so the stroke volume of the right side of the heart is going to increase, and the pressure with which that blood is ejected to the lungs is going to go up. So you sent more blood to the lungs under higher pressure. And because the right side and the left side pump the same amount of blood, when that newly oxygenated blood comes back to the left side of the heart, what are you going to do? You're going to add more blood back to it. You're going to stretch it, line up those actin and myosin. So what's going to happen in the left side of the heart? The left ventricle is going to stretch, line up those actin and myosin, so it is going to send more blood out per beat, so that's going to increase your stroke volume and increase your systolic blood pressure. Now that's in a normal heart. But watch. Let's say, for example, and I used this before, it's a good analogy. If you work as a CNA, right, and people call in sick because they've stayed home to read the textbook. That's 2 if you're counting. Then, hang on, I gotta plug this in. So, this is as good as their heart's ever gonna contract. So, in a person with congestive heart failure, if they're aligned, their actin and myosin are aligned, and that's as good as it's going to get ever for them. Do you want to be sending more blood, more venous blood, back to the right side of the heart? If you send more venous blood back to the right side of the right side of the heart is fine. It's fine. No problem. Didn't have a heart attack. The left side did. It's fine. So what's the right side of the heart going to do? It's going to stretch. And when you stretch the right side of the heart, because you added more blood back to it, the actin and myosin are going to line up better. So the force of contraction is going to increase. The amount of blood, stroke volume ejected with each beat is going to go up. And the pressure with which that blood is ejected to the lungs is going to go up. But now, remember, the amount of blood pumped by the right heart is equal to the amount of blood pumped by the left heart in a normal heart. But you ain't got a normal heart. You got a heart that had a heart attack. And remember, in people with CHF, bad CHF, the left ventricle at rest, the actin and myosin are lined up as good as it's going to get. So if you add more blood back to the left ventricle of someone who's got CHF, you are now going to overstretch it. And if you overstretch the left ventricle, the actin and myosin are now not aligned well. So remember, the only place that determines how hard that muscle contracts is where the actin and myosin overlap. At rest, it was like this. So the heart was contracting okay. What did you do? You went and added more blood back to the right side of the heart, and that came back to the left side. The right side is fine, right? Stretch it, no problem. But now you're sending more blood to the lungs, and all that blood is going to make its way back to the left ventricle. The left ventricle is damaged. So now you're going to overstretch the left ventricle. And when the left ventricle gets overstretched, the alignment of actin and myosin are bad. It's bad. And when those alignments of actin and myosin in someone with congestive heart failure are bad, the force of contraction of that left ventricle becomes weaker. So the stroke volume goes down and their systolic blood pressure goes down. So now, watch. Because you added more blood back to the left side of the heart and it was damaged, it's got more blood in it. There's more blood in that left ventricle. But it's contracting weaker because that left ventricle got overstretched. So the amount of blood ejected with each beat, the stroke volume is going to go down, and their systolic blood pressure is going to go down. And the amount of blood that's left over in that left ventricle is going to increase. So where did that blood come from? That blood came from the left atrium. And where did that blood come from? Well, that blood came from the pulmonary veins. And where did the pulmonary veins get their blood from? The pulmonary venules. And then the pulmonary capillaries. And capillaries are one cell membrane thick. So the pressure in the capillary, which is normally very low, that pressure begins to increase. When that pressure increases in the capillaries of the lungs, it will force water fluid from the capillary into the alveoli, and you get pulmonary edema. So people will start getting water on their lungs, and you'll learn this in nursing school. It sounds like little Rice Krispies, because water is affected by gravity. The first place that you'll notice it is in the bases, the lower portions of their lungs. And as that congestive heart failure worsens, it will move higher and higher and higher into the lungs until they actually start pushing fluid into the larger airways, and you hear that gurgling. That's the death rattle. The death rattle is the result of the left ventricle failing and that blood backing up into the lungs. So, look, in a person with congestive heart failure, do you want a lot of venous blood coming back to the heart, to the right side of the heart? No, because if you do, you're going to overstretch the ventricle. That's why people with congestive heart failure, as it worsens, they have to sleep more and more and more upright, because you learned there's no pressure in the venous system, and by gravity you will force that venous blood to be stored in your legs by gravity. So if you lay down, all that venous blood that used to be stored in your legs is now going to come back to the right heart. If you send more blood, venous blood, back to the right heart's fine. It's going to stretch, line up those actin and myosin, and it's going to send more blood to the lungs under greater pressure. And now that newly oxygenated blood is going to try to come back to the left heart. But remember, your left heart's jacked up. And at rest, right? When you were sitting up, it was as good as it gets. Then you lay down, and now you're going to overstretch that ventricle. So where's that blood going to back up into? Left atria, pulmonary veins, pulmonary venules, and they get congestive heart failure. So one of the questions that physicians will ask is, how many pillows do you have to sleep with? And as the CHF gets worse and worse, the person will say, I have to sleep with 1, 2, 3, to the point where the CHF is so bad they can't sleep in bed anymore. They end up sleeping in a recliner. So that's the pathophysiology of congestive heart failure. I hope it helped.